Hello, good evening, and welcome to tonight's webinar, Introduction to Python with TI-Nspire CX II technology. Our presenter for this is Sanjeev Meston. I have seen Sanjeev presenting at numerous conferences, both in Australia and also overseas. Meanwhile, I'm Brian Lannon. I'm your host for this event. So once again, welcome. I enjoy hosting these events because I always pick up something new to learn from them as well as we listen to our range of experts. So without further ado, I will hand you back over to Sanjeev.
So thanks for the very kind introduction and welcome all the viewers. I am hoping you will be able to take something out of this webinar. Now, the Python actually is a new feature or an add-on to the TI-Nspire CX and the CX2 and the CX2 CAS. And as Brian mentioned, you do need version 5.2. Now, this is an hour session, so I'm hoping to first introduce you to Python on the TI-Nspire. I'll briefly talk about the compiler, which is also called the editor, and the output happens on a page which we refer to as the shell. I'll take you through the menu, that is the built-in commands, and how you could actually access those quickly. Then there are several Python modules that are available on the handheld. We'll go through each of those modules. Then, of course, while writing a code, indenting is one of the very important things. So I will focus on that. Then, of course, how to run a program. Then part 2, we will be actually writing some code and we'll actually execute our programs. And we will be looking at probably doing something with the loops. So it could be a while loop or the for loop. So that really is the intention for today. Now, in saying so, some of you may have never done any coding, and that's perfectly fine. Some of you may have done coding with TI Basic, which probably is helpful, but if you haven't done any coding previously, that's fine. And I must say, actually, the best place to start coding is the TI handheld, and I'll give you valid reasons for that. The first thing, if you try doing this on a desktop, you first have to install, of course, Python. Then you have to install some integrated development environment like PyCharm, or you need a framework like Django. And if you kind of hear these terms, you will start getting turned off or scared. But once you have done actually some coding on the TI-Nspire, where everything is set for you, you will actually have a fairly good idea as to what Python is and what framework is and what IDE is. And then, of course, you can install this on your desktop and use the Python application there. So in my opinion, the best place to start really is the TI-Nspire handheld, as everything is there for you. Okay, now, before I can actually start the introduction, what I may do is just kind of show you what we can do on Python. So I'm going to actually run some programs. Now, what you see over here is a notes page, and my notes page is actually going to talk to a code, which is the quadratic formula I've written in Python. So this is in Python, and it is actually going to pick up the information from here. So I can go and change this, let's say, to 5. So I've just created a quadratic, and it has got these roots. So we are actually going to look at how I could write a code to get these. So Python is going to pick up these coefficients for me from here. So let's do that. And I'm going to actually just run the program. So if I do Control R, it runs the program, and you can see actually it gives me the roots, the axis of symmetry, and the discriminant. Now, this particular program I have also written to actually include complex roots if they are not real roots. And I won't go through that at this stage, but when we actually go through the actual code, you will see that I've incorporated including the complex roots as well. So let's look at another simple program that I have written. And this one here is basically heads or tail. So if I run this program, it's asking me, do I actually want to toss a coin or roll a dice? So if I enter C, it's going to probably toss a coin for me, otherwise roll a dice. So let's go and do D, and number of times I want to roll this. So let's just do 10. and you will see it gives me the output over there. So the first time I rolled the dice, it gave me number 4, and number 6 actually has appeared 4 times. So this is all done on Python, and you can kind of see how quickly everything runs. This one over here is if I'm rolling a dice, and I can roll it say up to 1,000 times or 2,000 times, and this will just demonstrate how quickly everything happens. So I'm just going to run this program, and it says enter a number up to 1,000. So let's say I'm rolling this 700 times, and it says I rolled the number 1 126 times, and likewise number 6 127 times, and it gives me the count for each one of them. But interestingly, if I now take you to the next page, so that was the code. This is the output, which is the shell page. It actually sends this information out into the list and spreadsheet page, which is actually another application. So Python talks to the other applications as well. And if I just go to another page, you will see it creates a pie chart for me with the information that I had. So what I'm trying to bring out over here is actually Python talks to other applications as well on the TI-Nspire. Okay, let's look at another one. So these are like teasers just to tell you what are some of the things that I can do. This is an archery competition, and I've got some TI trainers. So Brian is there, Rodney, Jim, and Peter. So this is an archery competition, and you'll see how this runs. So it's Brian. Now that's the second attempt, fourth attempt, and fifth attempt, and now Rodney. So that's the target there. So it's all actually on Python. And then that's now Jim. Jim seems to be doing better than Rodney and Brian. And finally, Peter. And let's see who finishes on top. So if I click escape, it gives me the winning order. So Jim was there, and then it gives me the score. So 12, 12, 10, and 10. So it didn't take very long to run this program.
I'm not happy at coming second.
Yeah, so, I had put a timer there. If I hadn't put a timer, this program would have actually run instantly. And let's look at this one here, which is just...
sorry to interrupt you there, but there's a dialog box up in the top right of your screen. That's visible, so it's just saying Brian, Lannon, me or something, or host. I think you can minimize that and drag it away.
Oh, this one here. Yeah.
Yeah.
Okay. Yeah.
Oh, I'm happy to take credit for it all, but it's
okay,
probably not.
Yeah. All right. So this is another one, and this is actually more to do with graphics. So if I run this over here, you'll see actually it's created arcs of different colors. So you've got primary and the secondary colors, and you'll see how quickly actually the code ran over there. And probably just one or two more I could do. Okay, this one here. Let's skip this one probably, and just go to this one here, the last one. You'll see it's actually putting on the primary and the secondary colors with changing intensity. So the 3 primary colors, now it's the secondary colors, and it runs all very quickly. And of course, I put a control, and then of course all 3 colors mixed to give you white. So these are some of the things that we could do. And I've been playing around with Python on the TI-Nspire for nearly 7 or 8 months, and I have written over 100 programs already. I enjoy it, and it's fun. And I'm sure once you actually start writing a few codes, you'll love it as well. Okay, so let's move back to introducing Python on the TI handheld. So you will see once you actually go to add an application, right at the bottom, there is add Python on your TI-Nspire handhelds now. So like you add a calculator page or anything, the very last is add a Python. So when you're writing your first program, you'll select the new option, and then you will give your program a name. So I've just by default referred to it as program 1. So at the moment, I'm not running any program or writing anything. Now, one of the things that I need to mention over here, Python code is best executed when you are in the handheld mode, not the computer mode. There are some programs that may run on the computer mode, but handheld mode is always the preferred mode. And if you want to go to the handheld view, if you are not aware of the shortcut, there is Alt, Shift, and the letter H. If you do that, it will change you from computer view to handheld view. So it basically toggles. So H for handheld view, and if you do Alt, Shift, and C, it will take you to the computer view. So that's one of the shortcuts, although you could just go on top of the screen and change. So just a very simple program over here. I have stored A as 5. Now you will see for storing anything in Python, I use the equal to sign. So I'm storing the number 5 with letter A. So I've assigned, so you could call it store or assign, and then I'm saying let B equal 7. So when I'm doing actually any operations where I have to use the equal to sign, I have to use the double equal to sign in Python. So I can't use the single equal to sign, because the single equality sign actually is more for storing a variable. So if I do print A plus B in this case, now print is the equivalent of display on TI basic. So if I was running this in basic, I would say display. Over here I print, and print will actually display the outcome. So you can see over here now, this is a screen that I've got. So I've got 1, 2, and whatever I hash I put with the hash over there is basically adding a comment, and it's not a part of the code. So those also get counted in my lines. So at the moment, my cursor, you can see, is sitting on line 4. There are 5 lines, and it tells you where I am currently. Now, the good thing is, if there is any error when I run the program, it will tell me exactly on which line the error is, and I can go straight to that particular line. So at the moment, it's telling me my cursor is on line 4. So that's one good thing about Python. It straight takes you to the line where your error is. Okay. To run the program, I have to do Control R, but if you want to go through the menu, then you'll go menu, then option 2, and then 1. Okay, so I've given the shortcut over there for running. Now, when I run a program, it runs on a different page, and the new page where you see the output is called the shell page, which we call as the Python shell. You can delete a shell page, but there is no point deleting a shell page, because every time I close a file, whatever temporary information is put on that shell page, it actually gets cleared automatically. But while running the program, you can't clear the history on a shell page unless you use the clear option, which is actually under actions. You can clear it through actions. But normally when I run the program, I include this in my code. So I want a clear screen to start with. So I actually include it in my code to give me a clear shell screen when I start. You'll see that when I actually run the programs, or when we start writing, that how that can be done. So running a program is very similar to what we do in TI basic, just doing Control R. So this is the shell page now, and this is where my output is. So the result of A plus B is 12. So if I can just go a screen back here, I said A is 5 and B is 7, and I said print. And what you see in green text, it is actually a string which is put in inverted commas, and I've left a space between after is, because I want to display the result with some space. So the result is, and that's comma, and that's the calculation that is happening, A plus B. So it says over here the result is 12. So this over here is the shell page, and again the shell page also gives you the number of lines that are displaying, and it will always put the name of the program that you have run. So I was calling it program 1. So you'll always see that from program 1 import. So that's a default on the shell page. Okay, I need to clear that. Okay. All right. Now these are some of the built-in modules. The very first one at number 4 you see is the maths module, which of course we will be using often. Then you have the random module. If you want to generate random numbers or random integers or random symbols or whatever, you will use the random module. Then for plotting, I've got the TI plot library access. Then of course, if you are using the hub and the rover, they are fantastic. I have used it for the hub and the rover, and you'll see how nicely they actually run the codes. But today, unfortunately, I will not be covering the hub and the rover because I physically need to be connected to the hub and the rover. And of course, you need to see that happening. What's what my code is possibly doing when I'm running something on the hub or the rover. And then there are more modules under 9, and I'll take you to what are some of the additional modules as well. So here we look at the additional modules. So the first one is complex maths. So obviously that's with complex numbers. Then the second module is with time. And if I want to stop or pause a program, I can actually import this time module, and a whole lot of other things I could do with time. Now, the most important one, in my opinion, that I tend to use often is the TI system module, where I can talk to other applications. I can bring in information from other applications, or I can send information out to other applications if I have installed this module when I'm actually writing a code. So every time I want to use any of these modules, I have to import them, and we'll look at it when we actually write our code. Then there is the TI draw, and finally TI image. If you want to deal with images or graphics or logos, then that's the image module. So there are several modules that we could actually use on the TI-Nspire. Now, these are some built-ins, and built-ins is something that you'll be using very often. So the first of the built-in are the various functions. Then you've got the controls. Then you've got operators, then the various options for lists, and then type, of course, and finally, input and output. So you would have seen I use the print statement, which is an output. So I can go into input and output and pick up those things. So if I want to get an input from a user, I'll go into input and output. So we will look at that when we get to that. Okay. So as I was saying, if I want to clear history on the shell page, that's an option there, clearing the history, but otherwise I just can't go and delete the history. Indenting is something very, very important, because if you try to write code by hand rather than using, the built-in functions, you may go wrong with the indent and your code may not run. So these are some shortcuts if you want to just move to the next indent, and it moves in twos. So if you use the tab key, it will move you to the right, and dedent is again shift and tab, moving to the left. You can add comments by simply doing Control T, or you can uncomment. So when you actually want to add a comment that's not a part of the code, and it will put the hash symbol. Now these are some shortcuts which are very, very helpful. If I want to go to the beginning of a line, all I need to do is just Control and the number 8. If I want to go to the end of the line, Control 2. So at times you go kind of the cursor to the right or to the left. That's probably not a very good practice. If I start using these shortcuts, they are actually very helpful. So to jump to the top, now these are very similar to a list and spreadsheet. So on a spreadsheet also, if you want to jump to the top, you do Control 7. And if you want to go right till the bottom, you'll do just to Control 1. So some of these shortcuts you may be familiar with. Okay, so this just takes us through what are some of the things that are available in under the Actions tab. So I can open an existing program. I could create new. And at times I tend to create copies, something that is going to be repetitive. So if I have created program 1 and then I create a copy, it will by default go and give it the name program 2, or I could rename it. So you tend to use the copy option if I want to refine my code, but I don't want to lose what I've already created. So creating a copy is a very good option. And you will see when you get actually into a lot of coding, you'll probably want to create copies. And once you're happy with the final file, then you can get rid of the old copies that you may have created. So going back to built-ins, we had the functions. So under functions, you have got define a function, and then of course it returns. And then in the next screen, I've gone to controls. So we in coding use if, else, else if, and else, and then for loops. So all these number 4, 5, 6, 7 that you see are for loops. Then while loop. So this is best accessed via controls, and I highly recommend that we actually use the controls rather than trying to type in by hand. And then this is an important screen right on the right side where it says operators, and you will see for equal to I have to use the double equality sign, and of course the other operators are there as well. And of course, if I'm using any Boolean thing, then I can go to true and false. So these are the operators. Initially, of course, we'll be using operator number 2, which is the equal to one more often. And then depending on what we are trying to do, we'll use probably less than or greater than, less than, equal to operators as well. Under lists, these are the various options. So a list over here in Python is actually created within the boxed brackets or the square brackets. And if I want to add anything to a list, I'll use the append option in my code. If I want to remove an element from a list, I'll use the remove option. And of course, I could get the range, the work with list on a range, and I could give a step size. So we will be looking at those again when we start writing some codes. But a reminder that list actually goes in a square bracket. And when I want to start with an empty list, I'll just put the empty brackets over there with nothing in it, and then we can populate it with the append option. And next over here is showing us type. So we can deal with strings, we can deal with integers. So the first one, int, is integers. Then float, when I want to work with decimals. And then this is a syntax for rounding my output to certain number of digits. So if I want to write, if I want to calculate anything to 2 decimal places, so I'll do whatever my output is, comma 2 with the round function there. And that's for complex if I want to do complex rounding off. Yeah. These are the various inputs and outputs. So print and input is something you will use very often. Evaluate is again when you are using parameters and variables you want to evaluate. Then you will obviously use the evaluate option. And format is something you will start using more when you're working with strings and numbers. And format you would use with the print command, the way you want the information to display. Okay. So under the maths modules, now I won't go through each one of them, but these are some of the things that you have. So you have the constant, the Euler's number and pi, then you have the trig functions. And then the one that we often use is number 5, the square root. These are all built in. And the power, and you'll see I'll actually be using the power function often. So you can use power, but you can actually use a double multiplication symbol for power. So you can't use the power key. And talking of this, if you are in Python and if you actually use the power key, you will see it does something different. It actually goes and puts 2 multiplication symbols. So when you are in Python, some of the keys actually respond to Python code directly. So they may not be the they may not function as normal keys that you were hoping your CAS or your handheld would. It actually by default starts outputting some of the Python things that are stored behind those keys. So we look at that as well. Okay. The TI system import, again, you can see if I want to store something and open it in another application, I'll do store list. And if I want to bring something from one of the applications like the list and spreadsheet page or from the notes page as I did, I'll use the recall option. And if I want to exit from a code that I'm running, I can just use the get key or the escape, which is the equivalent of escape. So that's the only way I can get out of a running program. Okay, I think,
Right.
yep. Is there a question?
Yep, just wondering, Sanjeev, somebody's asked if it's possible for programs to be saved and accessed back through the library or catalog.
Oh, yes, that can be done. That definitely can be done. Yeah.
So just as we do with the TI basic programs.
Yes, correct.
Yep.
Yeah. Okay.
Thank you.
So that's just taking us to the random integer random module. So random integers, choice of a sequence, the random range, and random seed. So something that you're familiar with through TI basic as well. And then the draw import. So you can work with shapes and a whole lot of things. So you've got rectangles, circles, arcs. A lot of those shapes are there. Okay. As I said, with the hub and the rover, there's so much you can do, and the commands run so well and fast that I actually used to do coding for rover and the hub with basic, but now I actually find it much easier using the Python coding with them, and they run really well. So this is some comparison over here between basic and Python. Now this PowerPoint actually will be shared with you. I'll forward this to Brian, and he probably will be able to share it with you because I've got some links as well. But if we go through this, it actually shows you a comparison, some of the features that are common between TI Basic and Python, and of course also some of the differences. So I won't probably talk too much about these bits over here. And it just shows, how if and else if code would look in TI Basic on the left, and then on the right is in Python. And of course, you'll see there, we don't need any end statements in Python if I'm using any of these commands like if, so on. So once again, just some of the key ones I want to mention. So in basic, I'll use display. In Python, I'm going to use print. In basic, I use the wait command, and in Python, I'll use the sleep command. The comparison operator is a double equal to sign in Python, and assigning operator a value is just a single equal to sign, whereas in basic, you use the colon and then the equal to sign to assign, and the comparison operator is simply the equal to sign. So these are some of the differences, but I just find Python so much more quicker and convenient. Okay. So the other thing is when I'm writing code, so when I'm using operators, it will be in red. When I'm in doing string, it would be in green. So syntax highlighting, different parts of the program are displayed in different color. And auto indenting happens in Python. And there are inline prompts. So if I'm wanting a shape that I'm wanting to include, it will ask me where do I want to input the shape, whether I want the lines dotted or solid, and the color. So it's basically going to have all those questions it will ask you. So there will be prompts for you, and you can't go wrong. And of course, it's menu driven. And if you just go through the built-ins or the commands, you'll actually have no problems writing your code. I've already talked about that. Yeah. Okay. So these are some of the useful links. So there's the Python programming guidebook. Then there's a bulletin board. So all these links are active. And then there's 10 minutes of code. And yeah, if you want to ask questions or share comments, you can just go there. So there's a TI-Nspire Google group. All right, so that's about it from the PowerPoint. Now let's go in here. Okay, so as a starter, if you actually click on the home button and you go into documents, if you look at browse, If I just click browse for a moment, and if I go under my documents, so this is my documents, and if you click examples, double click that, and you will see there is getting started with Python. There are examples. So I'll just click that for you, and you will see it's actually got some starters for you. So that's a first program that you could actually run in Python. So there is these example files. Then there is an example of how to use the for command to run a loop, and heads or tails. There is another program there. So these are some very simple programs that you could actually access to your examples under my document. So that's going to be a good starting point as well. All right, let's move now to writing our first program. So if you all have your handheld, or if because you're on your computer probably, or if you're on your phone, then it may be easier if you want to use your computer. But if you're using your computer software, I would recommend that you are actually in the handheld view. And if you have your handheld with you, that's great. Okay, so let's go and start. So new, and let's go and add Python and my first program. Okay. So let's give it a name. So I'm just going to call it program 1. And I'm going to just leave that as blank at the moment. But if I just click that, it's asking me, do you want to use maths, random simulations, geometry, or whatever. So I'm going to start with blank for a reason, because these are the various modules I can add at any stage. So if I start with blank and I say, okay, this is what I will see. So what we are going to do is request an input from the user. And we are going to actually request input by way of, so we are talking of a quadratic, and we are talking the quadratic formula. So we know a quadratic is ax squared plus bx plus c. So we need the values for a, we need the value for b, and we need the value for c. So let's go and get that input from the user. So our starting point would be, if I just type in the letter A, and if I use the equal to sign, now I'm going to store something as A. So you will see it's gone red. And now if I go into menu, and if I go into the built-ins, you will see there is an option for type. And I want to actually use a float. So I'm going to use the float option. I could use the integer, but I'm actually going to use the float option. But as of now, I haven't told it that it's an input. So let's go and get the user to the input. So once again, if I go into built-ins, go right to the bottom, which is number 6, and go into input. So that's going to be the user input. Okay. Now you can type text over there, and let's just go and type some text. And you'll see the moment I put text, it goes green, and the text is a string. So I need to put that within inverted commas, and I'll just call it, let's say, a value. So you could call it anything, and I want to even display that. So that's it. So now what this is saying, the input would be any float number. It could be just integer value as well, or a decimal value. And we are going to store it. So let's just try to run this and see what happens. So if I do Control R, it's asking me what's the A value that I want. And of course, I haven't given any command to it what it should do, but it's just asking me for an input. And let's say I say 5, and that's all I've done so far. It's stored that input for me. So let's go back. And I'm going to do exactly the same thing. And I'm going to request an input, and we'll call this as B value. So I'll just copy that to save time. And you probably could do the same. And let's change that to B. And let's call that as B value. So if you are doing it along with me, that is great, because that's the best way to learn it. Try and do it alongside when something is happening. And let's do this. And I'm going to slow down over here, waiting for you all to have actually got these three input boxes there. Okay, so I have an input over here. So if I was to run it, it's going to ask me for the value of A, then it will ask me for the value of B, and it's going to ask me for the value of C. Okay. Let's go and do our next bit. I want to actually calculate the discriminant. And there are two ways of doing that. So I can actually define it as a function, and that's what I am going to probably do, which may be easier, but I could do it without defining the function. So let's go into menu, and under built-ins, under functions, the very first option I see is define a function. And this function, I'm going to just call it DISC for discriminant. Now you'll see define has gone in blue for me, and it's asking me the arguments. And in my case, the arguments are going to be A, B, and C, because that's what the discriminant function will need. And
sorry to interrupt there, Sanjeev. You mentioned C. I'm thinking the line up, it should be input C val.
Oh, yeah. Thank you for pointing that out. Yeah, that's great. Okay. Now, you'll see it's actually created an indent for me automatically. Do you see it's displaying block, and it's actually created an indent? If I was to type it in without using the menu, I would miss this colon. And if I miss the colon, obviously my function is not going to work, and you'll see that it creates the block. So best is to always use the built-ins. Now in the block, I need to actually give the discriminant a formula. So what is discriminant? I'm saving that as a formula. Okay, now this is something that I want you to notice. I want to do B square. So I'm going to type the letter B. And as I told you, I can't use the power key direct. I can't use the power symbol. But if I click the power key, now you will see that in Python, it responds differently. And power is a double multiplication symbol. So if I just click that, you will see actually the power key did something different. And it's actually giving me the power. So now I can go B square. Okay, so that's B square. So Python, the square or to any power, you need the double multiplication symbol there. Okay, now let's go minus, and then you will see all my operators are in red. Okay. Now we need to do 4. So you can just use the times symbol, go times A times C. So I have just defined what a discriminant is for me, and I'll just go and put that in the bracket just to make sure that everything is included. So putting brackets is safe. And now if I go here, I want it to return my programs. So just go into built-ins, and again under functions, you will see there is a return option. And what do I want this to do? I just want it to return whatever the discriminant is. Okay. So we have now asked the program to calculate the discriminant. So let's go to the next line, and I want to print this discriminant. Okay. So I need to get out of the define. So now I need to tab back. So I could use the delete and go back, but otherwise I could use the indent option there. And let's go and use the menu, and I want to print and see what is the discriminant. So do you remember how to get to the print? Built-ins and input and output, that's there, and finally print. Okay. Now I can add text over there. So let's say if I just say discriminant and yeah, discriminant, I could use equal to key and then use a space and then there, and let's go and say that I want to print the discriminant. Now discriminant for me is called DISC. So DISC. Okay. So let's run our program up to this stage now. So let's do Control R. It's asking me what's the A value. So 2. Enter. B value I'm entering is 3. And let's say C value is -7. And so I have an error. Okay, so we need to go and look at what the error is. Okay, so let's go back, and that's interesting. That's interesting. When you run programs, then you have these problems. Return disk, everything seems fine. Okay, let me just go and do this. That may probably solve the problem. Let's see if I did that. Let's do Control R and 2, 4, and let's say 6. Yeah, that's better. So discriminant is -32. So if I was actually running this to find the solutions, it will tell me I don't have a real solution. Okay. I could get it to do the axis of symmetry for me as well. If I want, I can add that. But let's go and actually write the solutions. So let's go back to our program, and we are going to use the if statement over here. So let's go back. Menu, and under built-ins, now I'm going under controls. So I actually want to do this one, if, else, if, and else. So let's do this, and you'll see it actually puts these by default. My indenting and everything is current, so I don't have to worry over here. So what's my condition now? So I'm going to say if the discriminant, and just to play it safe, I'll use the discriminant in that form with ABC. So if my discriminant, now I need to give the condition is, I need a bracket there, and let's say if my discriminant is greater than 0, what should happen? I will have two solutions. So in the block, I am going to put the solution. So let's call this as my first solution is R1. I'm using the letter R because it's a real solution. And I'm going to actually use the round option over here because I want to round it off to 2 decimal places. So I'll just probably type it in to save us some time. But as I showed you, it is available over there. And let's go minus. Now this is what I actually need to do over here. I am using some maths over here. Now if I was going to run this command, it may not run. By default, it is likely to run. So to play it safe, I'm actually going to go right on top, and over here, I'm going to add a module. And if I say maths module and from system import, now this is where I'm going to add a module, and anything that is available in the maths command will actually work from here. So I'm not sure what happened there. Maths module and from. Where is it adding? Ah, yeah, it has added. That's fine. So I don't need it twice. So from. Now what that does is anything that is within the maths module will be executed in this. So if you remember, I started with a blank, but I could have added maths straight away over there. The reason I didn't add it because I wanted to show you how I could add modules. Now, if I want complex roots, I can actually go again and add another module, which probably I may not use today. But if I go into more modules, and you'll see there is this module complex match, and I've added oh, not that. So menu and more modules and the complex, and we are saying from. That's what I need to add. Okay. And now if I go up, you'll see I've added the complex match module as well. At the moment, it says my cursor is on line 2, and there are 17 lines that I already have in my code. So let's go back to this where I was writing my formula. So I'm saying my first root is round, and I'm going to use negative b and minus the square root because I need the square root symbol. So menu, if you go into maths, and you'll see there is the square root option. So let's do that. So the square root of the discriminant. So let's go and do that. I'll just copy that. Now, I could have avoided defining this. I could have just calculated D, and I would have done it in a much easier way. And that's what I normally would do. And I'll show you the program that I've created. I've actually done it without defining the function. Okay, so what else do I need? So square root of the discriminant. And now I need to divide this by 2a, the whole thing. So I need a bracket. So I've got 2 brackets there, and I need a double bracket here as well. Just being careful with the brackets, and divide this by 2 times a. Okay, and I'm rounding this off. So let's go and do that to 2 decimal places. I should have that. So just making sure that I have the correct number of brackets. Okay. Let's copy this. I think I have an extra bracket. So let's see. 1, 2, 3. That looks right to me. Divided by 2a. So let's go and put 2a also within a bracket. I'm just playing it safe. It's always advisable to do that. And let's see if it has the bracket issue. Okay, let's copy this. And let's do the second root. And the second root, I should change that to plus. What if the discriminant, so I'll copy that there. And say, let's say the discriminant equals 0. Now, do you remember what is it that I need to keep in mind? I need to have 2 of those as an operator. And then let's go and do the block. And what should happen in this case? I won't have to worry about discriminant. So let's just copy this whole thing. And because it's just going to be negative b over 2a. So negative b, get rid of that, divided by 2a. So I've got 1, 2, 3. So I have an extra bracket which I don't need here. Hopefully that should all work. Okay. And let's round it up to 2 decimal places as well. Okay. Else, if at the moment I'm going to say, let's just say display the text. So you could just say print, and let's do the proper way, built-ins, and go to input and output, print.
Yeah, Sanjeev, I'm just thinking for the second root, should you have that as R2?
Yes.
Yep.
Since you mentioned
I'd like to claim credit for that, but yeah, a couple of our participants wrote it in. Yeah.
Okay, that's fine. Yeah. So it's pretty if you're running a webinar, you have to be mindful of all those things as well. And at times you miss that, especially when you're copying and pasting information. Yeah. Okay, so let's try to run this. And it says invalid syntax.
Do we need something more on the R there in the else if?
No, that's all okay. It's telling me the error is where my cursor is sitting, and I'm pretty sure it's got something to do with the bracket. So I've got 1, 2, 3 opening brackets, and I've got 1, 2, 3, 4. So there's a closing bracket there. That's fine. Let's see if I just get rid of this.
Do you need a third bracket after the C?
Here. 1, 2, 3, 4, 5. Yeah, so there is an extra bracket there, right? Okay, let's just try that. Let's see. Yeah, that's better. So let's do 1 and probably -5, and let's do 6. Again, I have an error. So it's telling me there is an error in line 11. Can't convert complex to float. So did I get my discriminant as negative? So line 11. Okay, so let's look at line 11. There. So it's got an issue there. Anyway, what I may do is I'll actually take you to this directly over here, and probably it's easier talking through what I've got here. And at times, just trying to fix an error can result in loss of time. So if I go here, so it's basically the same program that we've got. So I actually stored the discriminant as letter D. So I didn't work with, creating the discriminant. So I just said, let's get the coefficient of A, B, and C. It's exactly the same thing. I'm doing the discriminant over here, the axis of symmetry, and you'll see this actually is much simpler. So rather than using the discriminant, I've just used the letter D without defining the function. It works much better. So else if, and it's displaying this text, this quadratic has one repeating factor if D equals 0. If D is greater than 0, it says the quadratic has 2 distinct solutions. And the last step over here, you will see, because I've got C import, which is complex. So if the roots are complex, it will actually handle the complex roots as well. And this is probably a much easier and a better way to go. So I'm mindful of the time. I was hoping I'll be able to go through some more codes. But if I run this one, let's quickly run this. And let's go and give probably let's do 4 and then 5. Sorry, quadratic has 2 distinct solutions. It already ran the program for me with the information that I had. Discriminant is 356. The axis of symmetry is 0.6. Quadratic has 2 distinct solutions. So it basically ran the whole program. So if I go back here, it's already picked up the information from here. So if I change that to, let's say, +6 and run this over here. So let's run it. And now it says, these are my roots. So this is a much easier way of doing that. Okay, I'll probably quickly talk through another code that I have written to save time. So that's, this one is on coordinate geometry. So I've defined point A and point B with coordinates, and it's going to find the midpoint and everything. I can share the code with you through the file. So I'll actually email you the file straight away. It will be much easier working through the file. This one is for plotting points. So if I run this one over here, I've given a set of points and it does even the regression. So if I just take you back to the code over here, I had the X list, which I put 0, 1, 2, 3, 4, 5, and I created a Y list. The only thing I need to keep in mind is the number of values in the X list and Y list should match up. Otherwise, there'll be a dimension error. And this just does the plot for us. Let's do that. Heads or tail. I'll just talk you through this one. So I've done a max import and a random import, because it's going to, when we toss a coin, we just wanted to know whether it's a head or a tail. So the random module will do that. And if I toss a coin, roll a dice, then I'm looking for numbers from 1 to 6. So that's going to happen from the random import. So the first thing is I'm getting a user input. So the user is inputting, do you want to toss a coin or you want to roll a dice? So enter C for coin or D for dice. And then the next input is how many times do you want to roll the dice, or toss the coin. So number of times. So that's going to be a user input. Now I've created an empty list, which I'm calling is outcome. So outcome is an empty list over here, which is empty at the moment. And I'm using the while loop over here. So while I'm starting with 1. Well, I is less than this number n that I put. So if I put n as 10, so it says as long as I is less than equal to 10, keep running this loop. So I've used the while command and just going through this. So we are saying if the input from the user was C, then it's going to run the command to toss the coin. And if the, so because Python is case sensitive, I've used that twice. So if CD equals capital C or if CD equals lowercase c, it will accept both because the user may just type in the lowercase c. So that's in the if command, I've included both the possibilities. Now, if they type in C, that means we are talking of a coin. So in a coin, I need a head or a tail. So I'm using h is my variable I'm storing it as, and random integer, generate a random integer, which could be just 1 or 2. So if it is the number 1, if h equals 1, I'm saying treat that as a head. So in the toss, I'm calling that as a head. If it is not 1, else I'm saying treat that as a tail. So there'll be only 2 outputs. So if it is the number 1, it's a head. If it's the number 2, it's a tail. So I've used the else command over there. However, if the user had actually said D or had not put C, had put any letter else, then it says treat that as a dice. So in this case, it says generate a random integer between 1 from 1 to 6, including 1 and 6. And let's call this against toss, and I'm calling that as h. But this time, whatever the outcome is, store that number. And this is the important one, outcome dot append. Now dot append comes from the menu itself. If I go into built-ins and if I go into list, you will see there is a dot append. Append means it will start populating my empty list. So if I escape from there, outcome dot append, and we are saying I had called it as toss. So it's going to just append to that item, and right at the bottom of the while loop, I'll say once the complete loop is over, start the next loop. So I plus equal to 1. That's telling it, okay, start the next loop. So that's an important command over there as well. If I forget that, then it will not know, should I run the loop again or no. So that's important. And it's simply because I use the letter I to start with, I equals 1. So what that means is the next one will be I equals plus 1, which will be 2, and it will go up to 10. And that's where it will stop. And then finally, I'm saying just print the outcome. So let's run this command quickly. So it says enter C for coin or D for dice. So let's go and do D for dice. And how many times do I want to run it? Let's say 15 times. And it's just displayed that output over there. So it's basically as simple. I realize we are running out of time. I was hoping to do one with draw, which probably is more fascinating. So Brian, what I may do is share the files with you, and if you want to share it with the attendees and also the PowerPoint, probably that may be a good way to start. Of course, the video would be available in the YouTube channel for TI Australia, but I think it's a good way to start with some of these files. So that's
absolutely
me.
Yeah, thank you very much, Sanjeev. Now, people have been commenting. There's been a lot of activity in the chat there this evening, and people are saying, yeah, it's a pretty brave thing doing live coding, on the fly. and
You know,
you've managed.
it's easy to pick up errors. At times, probably it's not as easy. And yeah, but that's fine. I was hoping to do another one, which was probably much shorter, which was about 6 or 7 lines, but that's fine. Yeah.
So thank you once again for joining us. Wishing you well for the remainder of your evening. We're hoping that you're subscribing to the newsletter. If you're not, then there's the link, and that will keep you up to date with upcoming events. Any further questions, there's the phone numbers. And thank you once again to our expert Sanjeev, and good evening to all.
Thank you.